I want to take you back just a little bit and still trying to understand the technology part of
Sure.
this.
Yeah.
Tell me about what is this filterless thing? What have you built that the world hadn't figured out?
Yeah, so I mean, filterless systems have kind of sort of like existed, but filterless is, I would say, more of a overarching word. There's nuances to it. So what's existed is, for example, your vacuum cleaner is filterless. It uses builds a cyclone inside the vacuum cleaner that makes heavy particles settle and the rest of the air leaves, so it can't capture fine particles, right? So what in the industrial scale, that's called a cyclone separator. Then you have something called an electrostatic precipitator. These are there in cement, steel factories, sizes of buildings, huge plates, electrodes, basically generating bunch of ions. These ions stick to the pollutants, and then the pollutant sticks to that opposite charge plate. Very large. They have ozone generation issue, electromagnetic noise issue, but all cement, steel plants have one, right? Very expensive, like 20 crore, 100 crore type installations. Then you have something called photocatalytic oxidation, which is using light and chemistry with titanium sheets to again charge particles of one form and then make them settle, which is what government tried with some of these Vayu project installations in the country. And then comes what Pran is doing now. We didn't invent the physics. What we said is, how do you take the physics and actually make it in a form factor and a size and the performance that allows people to use it abundantly? So we also charge particles, right? But that if you see Pran's Mark II versus all the other guys, for the first time someone's taken this physics firstly and made it vertical. All of these have horizontal airflow. Pran has a vertical airflow. Second is, none of these have like large fans attributed to. So there's like a huge pipe carrying the dust, goes through this, and then whatever arbitrary amount of air leaves from the other side, and the fan is somewhere really far. For us, the fan is right next to the core. Now, why that makes it really hard is because suddenly the force on the particles exerted by this powerful fan is greater than the electrical charge we can use to separate it. So it's really hard. How do you separate like PM1 sized particles with that? Second is, you want to separate it, almost 99% type efficiency with the separation. If you use a lot of energy, it becomes unsafe because dust itself is explosive. Right? So when we look at a pigment company, etc., even just rubbing it at the right energy level in your hands can cause a dust explosion. It can burn down the factory. So when you're charging particles, it's like a bomb, right? So if you're charging particles and you're not able to do it at a low energy level, you're making a very unsafe core. So how do you make a safe core in that 6-foot form factor with the fan right on top? Then couple it with an automated cleaning system such that the dust can be recovered and put back into production process, and to do it at a price and safety form factor, like the where it's plug and play, a single person can move it around and so on. And then to add to the layer of complexity, the Mark II uses as much energy as a gaming computer.
So that's not a lot at all.
Yeah, it's like 1200 watts for the Mark II. And then to put it at the price point which competes with every technology that's existed, which you are phasing out, and then all the intelligence. So the filterless tech, just the balancing of that physics is incredibly hard because one, you can't see the particles. How are you running the test? So you have to engineer the test system that will allow you to test this core. Then you'll continue to optimize it. There's no simulation platform to do it. The world's most advanced simulation company, ANSYS, is a partner of Pran's. If their software was not able to help us build this, which means we had to build the models ourselves and also then do it experimentally to validate whether it holds true. And to do experimentally means to build the experiment itself, right? That is what took 5 years to accomplish, because you're inventing stuff every day, right? And you're going after first principles and saying, hey, but ion is only created at 4500 volt, which means I can only start at 4.5 kV. Then as I go at 4.5 kV to say 10 kV, but if I don't have enough distance between the opposite poles, it'll create a spark. If a spark is created, it can cause a dust explosion. So there's so many constraints which you have to rely on first principles to do it.
And so what did you figure out? Like, what is you said the physics already existed. You found a form factor for
Physics that existed is how to create a charge, how to charge a particle and collect it. That's all that we've borrowed. Yeah.
Right. And the rest of it, the form factor, the affordability, the sort of making it venture scale and sort of
Safety. And efficacy was the hardest part. Like, because as soon as you blow more air in, your efficiency drops. Now to offset this efficiency, you have to increase energy. If I increase energy, sure, I'll capture more, but then it's a dust explosion risk and
Right.
an ozone gas risk. I can't do that either.
What I'm actually trying to get at is, if this problem's plagued us forever, which, by the way, it's very interesting. You were telling me earlier that your parents or your grandparents, some older couple, were saying that we would just think, "Aaj hawa kharab hai, aaj hawa saaf hai." I thought this is a post 2015-16 phenomena, because I don't remember Delhi air being like this back when I was a school kid. Do you think it was like that? No, right? Like when we were younger.
Maybe we didn't measure.
Yeah, but bro, I mean, being in Delhi is a unique experience in the winter because you can see it. You don't have to measure it, right? It's a very aesthetic experience more than anything else. Like there are certain days where it's, and to be very fair, it's the same for Mumbai. Like maybe on this present day, I don't know. But if you fly back to Mumbai, you can see that it's more grainy and dusty in Mumbai right now than it's in Delhi.
It's terrible. If you see these Instagram brokers, right, who show these 50 crore, 100 crore houses in Bombay, it's like, there's no view. What are you selling? It's like only pollution outside. I can't see the building that you're...
Right.
Yeah.
But no, the larger point I'm trying to drive is that there is an aesthetic element. I'll give you another example. This is my hypothesis, completely could be stupid. Very early on into being in America, I went in 2017. And so this was post-pollution awareness in Delhi. And I remember clicking a picture and I was like, यार यहाँ तो मतलब ऐसे sun one भी बड़ा clear दिखता है, ऐसे photo लो तो मतलब. And I later realized that's the dustiness of this land. Like it's so dusty that you can see it in pictures. You can see aesthetic difference. In Delhi, pollution's an aesthetic experience. And I remember very clearly it was not the case. These days, it's been very windy around here. And not only that, I think it rained a few days ago. And if you drive right after we are done at 6 or 7 when the sun is setting, it's actually beautiful. A sense of beauty I haven't seen in a long time. It's still about 110 here. Yeah. What I'm trying to get at is that this idea that pollution existed forever, are you sure about that? Like, is that a measurable phenomena? Do we know about that?
Yeah, I mean, so I mean, you have to check the dates, right? But even historically, there was a time, not just in India, but even like take New York, right? New York went through the Industrial Revolution, etc. It had pollution. Same with Britain. So
Shanghai very recently.
Correct, right? And the way they solved it in China is they literally just moved things further away. Apart from, regulation, etc., they said, let's just disperse pollution over a larger area so that it's not concentrated. And that's, like, I don't support it at all. Please, whoever's watching, do not borrow from this, right?
Right.
Because what industries here have started doing is they've increased the height of the chimney so that the dust disperses over a larger distance. Right? But it's criminal to do this.
Yeah. Why I'm asking that is because if over 40 years this problem has existed, to my memory it's 10 in Delhi, but say it's even 20 years of very capable, ambitious, well-educated, fairly resourced people have come and gone, and nobody else has attempted a solution like yours, because if the physics existed, and it's a question of, and by no means this is to trivialize what you've done. And if the physics has existed, and it's a question of form factor and affordability and sort of figuring out the market points like that, either you figured out something extremely innovative, which was a hard problem that only you could cross because you put your mind to it, or there has been enough incentive to solve this problem. Why else has nobody figured this?
It's like...
what is the defining obstacle?
You need to care like incredibly deeply to commit your life to doing it, right? I accepted the outcome of failure when I started it. That's so that every day I'm going in is with like a, to optimize upside. Very few, and I was also like incredibly lucky to have a certain privilege that I've been building things since I was very young. Got like when during my formative years, got the opportunity to work with Ramesh Raskar, right? Then had the opportunity to go to a great college, and in this got a lot of different unique exposures, right? Had I not built those products before, I would have not had this Apple-esque design first thinking to build these things. Had I not solved the ambitious problems with Ramesh Raskar's team earlier, I would not have the risk-taking ability or confidence to do this, right? Or not going to a great school where I was forced to learn fundamentals, I would never been able to solve this problem. So it was a right place at the right time kind of situation. I think there are definitely people way smarter than me who could have solved this problem earlier. I think it just at that time, the old mindset used to be if you work hard and build a career, the future is going to be great. So it meant how do I make most money for my family and buy a good house or buy a good car, and that is what the pursuit was. For our generation, it's not for everyone, but for many of us who understand the numbers, it is like, hey, there's an existential threat to humanity and civilization from climate change. And in all things climate, what's affecting people the most today is poor air quality. So that urgency will come from our generation more than it came from previous generations. Like environment was always the least exciting, least sexy part of the engineering domain, right? People say I want to build aircrafts, fighter jets, rockets. Never like I want to solve environmental issues. People thought you're lame for trying.
It is pretty lame. Like,
Yeah,
I mean,
like-
no offense. No offense. It is the least sexy part of any conversation.
Yeah.
And I'm not saying this because I find it the least sexy. I also do. But the larger point is, try interesting anybody in a conversation about climate change anywhere except where, pretentious people get around and pretend that they're very smart. It's very difficult to get an organic person on a train or a bus to be like, "Abhi terko pata hai climate change ho raha hai?" It's like, "Kya bata? Mere ko bata." Nobody wants to know this, bro. Like, it's a needless headache in the back of my head. I can do nothing about it. There's diffusion of responsibility. Problem is too scaled. And guess what? I'm still alive today, and I'm going to be alive tomorrow. So there's many ways in which you can distance the problem away from you. It's like I've never been very fond of climate conversations. It's very boring.
So the only way to make it exciting is to make it aspirational. Electric cars were boring as hell until someone came and built like a ultra nice looking futuristic electric car. Suddenly the industry popped up, right? That's what you have to hack. Space. Everyone thought governments build space
Scale solutions, yes.
Yeah, and then came Elon Musk, and most of the space programs in the world today are being done by SpaceX.
Right.
And I say space programs, like I mean
Launches.
number of launches per year.
Right. Or 90%.
Yeah.
Right. That's the figure.
That's
right.
a private business that someone's running.
So 90% of all space flights to the International Space Station, to the space, whatever, satellite launches are controlled by a private entity.
Yeah.
Who is now also de facto Prime Minister of the US. That position did not exist until like January 20th. Right? Are you in touch with him?
With Elon? Not Elon directly. Many people on his team are investors in our company. So we have like first degree connect if we need to, but there's never been you want to be very mindful when you get that. If you want to talk to him, you have to have like I remember the guy telling me, hey, don't talk to Elon for 15-20 million. When you need like couple 100 million, you should talk to him if at all you want to go down that.
Very
that
interesting.
Yeah.
Does Tyler speak the same way off a microphone as well? Very like full sentences, self-sufficient.
Tyler is, I mean, I really like how deeply he thinks before he answers my question when I ask him.
Bro,
when my questions are really not that like hard, but he wants to give me the right answer because I will run off in that path and try to attack it. So for example, I'd asked him how to get this one big person to lead a 30 million type of round at like 11 in the night, and he thought about it directly. It's like, they still think that India is a country of goons, etc. The underlying message comes is that if this technology and company is so great, why aren't their own people funding it? That's the barrier you have to cross. That's what Tyler told me. There's no issue in making the intro, right? He said, figure out that answer before you go into that meeting.
That's solid.
Yeah.
I also think if you've ever, because my consumption of him is, I don't know if I've read his blog, Marginal Revolution.
Yeah.
Right? I've read the blog and it's literally tweet-sized.
Yeah.
Blogs that he puts, very brilliant.
His emails to me are one-liners.
That's it, right?
Yeah.
I think I've probably exchanged an email with him when I was in college because I was that big a fan. And if you listen to his podcast also, it's the most different podcast in terms of the questions that come up because those questions have very little to do with the person there. They're almost ancillary in a way that you discover the guests' preferences, their tastes, the way they think from those questions. Like as a questioner also, it's a very interesting approach.
He just said a few days ago, the limitation of AI is humanity.
Which means that
our ability to develop the AI is what limits the AI. When it learns how to develop itself, it's going to compound like that level of clarity to say in one sentence. I think it's
genius. If you are interested in my conversation with India's best, then you can listen to us exclusively on Spotify also. There's a link in the description. Press it. Listen to us as you walk, as you're in the train, as you're driving, as you're working out, as you're flirting. You'll still like it.